Okay, so this video is for one of the projects, short little projects that you're going to do this second week of online learning. And this is going to be find your own Pythagorean triples and calculate the angles. So I'm going to show you guys a quick little math process that leads us to a most excellent equation to find our own Pythagorean triples. So c squared equals a squared plus b squared. A quick reminder, a Pythagorean triple is when all a, b, and c's are whole numbers. So we're going to have a few other variables here. I'm going to introduce variables r, s, and t. And r, s, and t are going to be whole numbers. And there's one more restriction on, which one is it, r, that we're going to discover in a moment. But it's not a bad one. Basically, r just has to be an even number, and that'll take care of everything. All right, so my a, the shortest side of the side of the right triangle, is going to be the expression r plus s. My b is going to be the expression r plus t. And my c, the hypotenuse, is going to be r plus s plus t. So basically, we're going to figure out a scenario that if we choose a couple small little numbers here, we can generate Pythagorean triples. So that restriction, let's calculate that restriction very quickly by substituting these expressions into the Pythagorean theorem. So I have c squared is really equal to r plus s plus t squared. And that's really equal to r plus s plus t times another r plus s plus t. And r times r, big FOIL here, r squared. R times rs is rs. R times t is RT. S times R is another RS. I'm going to do like term columns, so I put the RS right underneath another RS. S times S is S squared. That's a new term. And S times T is ST. And lastly, have to distribute now this t, and we're going to get some repeated terms here as well. So t times r is another rt, t times s is another st, and t times t is a t squared. So we'll add all these together, and we get an r squared, an s squared, and a t squared, plus 2 RS's, plus 2 RT's, plus 2 ST's. All right. Don't worry if this part's confusing. You're not going to have to do this part yourself. I'm just showing you where this formula comes from. The formula we're going to use at the end here is going to be a little bit easier than all of this. Okay, the A squared, well, a is really r plus s, so r plus s squared is r plus s times another r plus s. This is an easier foiling. R squared plus rs plus s times r is another rs plus s squared. And then for b squared, we have b is r plus t. So that's going to be an r plus t times another r plus t. And we'll quickly FOIL that out. R times r is r squared. R times t is rt. T times r is another rt. And t times t is a t squared. And we'll just combine our like terms there. RT. All right, so now we're going to substitute these three guys into the Pythagorean theorem for a squared, b squared, and c squared. Okay, so c squared, r squared plus s squared plus t squared plus 2rs plus 2rt plus 2st equals a squared, r squared plus 2rs plus s squared plus b squared, r squared plus 2rt plus t squared. Now I know this looks like a big mess, but oh wow, life is about to get so much easier. Check this out. We can subtract an s squared from both sides. So those terms go away. We can subtract a t squared from both sides. Those terms go away. We can subtract a 2rs from both sides. Those terms go away. We can subtract a 2rt from both sides. Those terms go away. We can subtract an r squared from both sides. Those terms go away. And what are we left off with? We are left with our condition. 2st has to equal r squared. That must mean st is equal to r squared divided by 2. So that's the main key. Moving forward, grab another sheet of paper. All right, let's copy all of the key info from that last sheet of paper. So c squared equals a squared plus b squared. A is going to equal some r plus s. B is going to equal some r plus t. And c is going to equal some r plus s plus t. And to make this work, we must start with st equals r squared divided by 2. So this is my condition. And as long as I meet this condition, I'm going to get a Pythagorean triple. So let's start with the only real restriction we're going to get here is r must be an even number. Okay, I'm going to do 3 examples of what I want you kids to do. I want you to create your own Pythagorean triple and then calculate the angles. Okay, so what you're going to do is just pick a random r value and just make it an even number. Okay, I'll start with a small even number, r equals 2. Okay, so now let's use our condition to figure out what s times t is. St is going to be r, which I've just chose as 2, squared divided by 2. So st, 2 squared is 4, 4 divided by 2 is 2. So st equals 2. So now I just choose any two random numbers that are whole numbers to make a product of 2. So if s equals 1 and t equals 2, and my r equals 2, this will generate a Pythagorean triple if I substitute them in. So my a value is r plus s. My b value is r plus t. And my c value is r plus s plus t. And we have 3, 4, and 5. A Pythagorean triple. Okay, let's generate another Pythagorean triple, 2 more actually, and then I'll show you the last step, calculating the angles, which is actually, just call the smallest acute angle A and the medium or the larger acute angle as B, call the right angle C. We're going to get the measures of angle A and B. All right, one other example. Actually, I'll do 2 other real quick. R is 4. We pick a even number. Okay, so ST is R squared over 2. So 4 times 4 is 16 over 2 is 8. So I know that S times T has to equal 8. I can choose anything that are whole numbers. So I could choose S equals 1 and T equals 8. I could choose S equals 2 and T equals 4. Or I could reverse those, just 2 whole numbers that multiply together to be 8. So we have R equals 4, S equals 1, T equals 8. That's going to generate a Pythagorean triple. And then R equals 4, S equals 2, T equals 4. That's going to generate a different Pythagorean triple. Now I will say that if you have things that can be factored out of your 2 factors, your 2 S and T's, it's not going to be the lowest Pythagorean triple, and we'll see that in 1 second. So my A value here, it's R plus S, so that's going to be 5. My B value is going to be R plus T, so 4 plus 8 is 12. And then my C value is the 3 of these numbers added together, so that's 13. And we have another Pythagorean triple, the 5, 12, 13. Again, we'll label the smallest angle as A, the medium angle as B, and the hypotenuse as C. Okay, this other R, S, and T values that I generated, 4, 2, and 4. So R plus S is A, so that's 6. R plus T is B, so that's 8. And then the C value is all 3 of these guys added together, so that's 10. So this actually isn't a different Pythagorean triple than what we already had. If we divide 2 out of all of these sides, we actually get the 3, 4, 5 all over again. So All right, one more larger example, and then we'll go back and quickly calculate all of the angles using trig. Okay, so quick reminder, A is R plus S, B is R plus T, C is R plus S plus T. And my situation is ST has to equal R squared divided by 2. So R is an even number. I'm going to use my calculator for help with this one because I'm going to generate a large one. So let's say R is equal to 14. So ST is going to be 14 squared divided by 2. So I think that's 98, but I'll just double check. 14 squared divided by 2. Yes, it is 98. So I just need to think now of two numbers that multiply together to be 98. And 98 divided by 7 is 14. I don't like that. Let's do 98 divided by 2, 49. Yeah, let's do 2 and 49. Okay, so R is 14, S is 2, T is 49. We'll generate the Pythagorean triple. R plus S is the A value. R plus T is the B value. So what is that? 63. And then R plus T plus S is the C value. So this is an unknown to me Pythagorean triple. Just double check that I've done all of this right. I've done this correct. 16 squared plus 63 squared should equal exactly 65 squared. And I typed in 36. So let's try that again. Oh, thank goodness. Phew, oh, I got scared there that I goofed something up. All right, so Pythagorean triple generator. And then to finish off this little activity, after you label the angles, calculate the measure of angle A and the measure of angle B. And we're going to do that with trig. All right, so you can use any trig you want. Finding angle A. Let's just call this the hypotenuse opposite the right angle. The side is adjacent. You can use any sides you want because by the time you're at this step, you'll know all three of the sides. I just chose those two. Okay, so hypotenuse adjacent cosine is the trig function that uses adjacent over hypotenuse. Substitute the numbers and variables from the problem. Cosine of angle A equals 63 divided by 65. That means the measure of angle A is going to equal the inverse cosine of 63 over 65, whatever that is. Inverse cosine 63 divided by 65, close parenthesis. And it's 14.2500 degrees. 14.3 degrees. Then we can just subtract 90 to get the complement. Use the positive version. And that's it. So use the Pythagorean theorem generator. You're going to find five Pythagorean triples and then calculate the measures of the angles.